Hey class, today we're going to learn about trigonometry. Specifically, we're going to learn about right angle or 90-degree trigonometry. First thing you have to know are the names for the sides or the legs of a right triangle. So on this triangle on the left, what you guys should know is that the right angle, the 90-degree angle, is the side that looks like an L right there. That's your 90-degree angle. You're also going to be given an angle theta. So you're going to be given an angle here or possibly the other side, the other corner. And you're going to see this little O with a little curve thing there. And that is your angle. And that is a Greek symbol called theta. So that just means angle. Once we have those two things down, we have to be able to name the legs of the triangle. So here's how you do that. Furthest away, so directly across from the 90-degree angle, we call that the hypotenuse. And directly across, all the way over here, far away from the angle theta, that is going to be opposite. And the last angle, the one that is touching the angle theta, like right there, that's going to be called adjacent. So the hypotenuse is going to be furthest away from the right angle. It's going to be the longest line, always. That's going to be the hypotenuse. Furthest away from the angle theta is going to be opposite, and the last angle touching the angle theta, that's not the hypotenuse, is going to be the adjacent. So let's do some practice. Over here on the top right, if I look at this triangle, I can see right here, that is going to be my 90-degree angle, which means furthest away from there, that is my hypotenuse. I'll just put H. Now I have to give it an angle theta, so my angle theta I'll put up there. Which means that furthest away from my angle theta is going to be my opposite, so I'll put O, and then right here I'll put A for the adjacent leg. And let's do one more practice problem. So let's say we've got a triangle down here on the bottom right. It looks like this is our 90-degree angle right there, and let's say I put theta over here. Maybe you could pause it and try to figure out the legs right now. I'll go ahead and do it, and I can see that this is the longest leg, so that's the hypotenuse. Furthest away from our angle theta, that's going to be opposite over here, and that's going to be adjacent over here. Now, in case you didn't figure it out already, if I switched where the angle was, let's say over here in blue, I made this the angle theta, the hypotenuse will stay the same, but the opposite and the adjacent will obviously switch. Okay. Let's dive a little bit deeper here. You guys have probably seen these things on your calculator. You've seen sin, you've seen something called cos, and you'd see something called tangent. Now when you're in your calculator, make sure you guys are in degree mode. Again, let me put a little asterisk here. Make sure you're in degree mode. If you don't know how to do that, make sure you ask me in class. If you have a graphing calculator, a TI, there's a mode button towards the top, and you hit that, and it's a few things down where you can choose degree or rad, which is radian. You guys want to be in degree this chapter. Okay, so what you guys need to know is what these represent. A sine of an angle, so if you have a sine of an angle, if you went into your calculator and typed in sine of 30 degrees, you would get 0.5, and we got to figure out what that means. Okay, these things are actually ratios of sides of triangles. Okay, so it's almost like saying, you know, if you have a little brother that's 3 feet tall and you're 6 feet tall, your brother is 1/2 the height. Okay, or if you have a younger sister that's 4 feet tall and you're 6 feet tall, that younger sister is 2/3 your height. And that's what sine, cosine, and tangent are. So if you have the sine of an angle, what that's doing is it's comparing the opposite leg of the triangle relative to what I'll put as HYP, the hypotenuse of the triangle. If we have cosine of an angle, that's relating the adjacent leg to the length of the hypotenuse. And tangent of an angle is opposite leg divided by the length of the adjacent leg. Okay, so let's say that you guys do sine of 30 degrees, and your calculator says it's 1/2. What that means is that the opposite leg is half the length of the hypotenuse. That's all it's saying. It's just telling you how long one leg, one side of a triangle is compared to another one. Now there's a way to remember this, okay? Sine is opposite over hypotenuse, SOH. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. So they call this SOHCAHTOA. And I'm sure your geometry teachers have talked about it, or if you're not in geometry and studied these things yet, eventually they'll get to it. And sometimes they have a little funny story about it. So you should just remember SOHCAHTOA. You actually only have to remember sine and cosine. Rarely are we going to get to tangent. So you got to remember sine is with opposite. Sine is with opposite. Cosine is with adjacent. All right, so that's the background theory you guys need to know. You guys need to know how to identify legs of a triangle and need to know the sine and the cosine and how they're related. And that's with the opposite over the hypotenuse and adjacent with the hypotenuse. All right, so let's move on a little bit here and let's talk about how this is going to relate into physics here. So let's say we've got an object. We'll just make it a box like right here, okay? And we've got some force pulling at an angle. And I'll have to denote where that angle is. So a lot of times it's with the horizontal or the horizon, okay? So there'd be an angle theta there. What we're going to do is we're going to draw like a right triangle, okay? So we're going to draw this, okay? So basically what we have is a triangle right here. We've got this, this, and that, and we've got our angle theta right there. And I'm going to just call this leg force. That's the angled force on that block right there. What I'm going to do is I'm going to call this F of y, because it's kind of like a force in the y direction, up and down. And this is I'm going to call F sub x. Now, if we know that the sine of an angle, by definition, is the opposite over the hypotenuse, well, hopefully you guys know by now that this right here, I'll put this in blue, this is our hypotenuse, this is our opposite, and this leg is our adjacent. So if the sine of an angle is opposite over hypotenuse, then the sine of the angle is going to equal opposite leg, which is Fy, you can see that right there, divided by the hypotenuse, which I'm just saying is our angled force, F. And algebraically, we can solve for Fy. So F sub y is going to equal F times the sine of theta. So this right here, this leg, is equal to F sine theta. And I could do that with cosine, and I would get F of x equals F cosine theta. So this right here would be F cosine theta. So when I give you an angled force, which I'll put here in blue, okay, you're going to draw your right triangle, kind of like I did here. You're going to find out which force, which leg is opposite and adjacent, and then you're going to realize that the opposite leg is always going to go with sine, and the adjacent leg is always going to go with cosine. So I'm going to go ahead here and try to do a couple examples here. Again, let's go back to this block. Okay. So somebody here, I'm going to say, is pulling this block with a force of 50 newtons. Okay. And in the picture, I'm going to say that that angle, theta, is maybe, I don't know, 40 degrees. So what we can do is we can make this into a right triangle. Okay, so we're going to make this a right triangle. And since this force is up and to the right, you kind of enclose in that angle theta. So you make the angle theta within your triangle. So I'm going to draw this going to the right, and I'm going to draw this going up. And the reason why these are going to the right and up is because this original force is up and to the right. Now that I know that this leg, this vertical leg right there, that is the opposite, and opposite goes with sine, I know that this is going to be 50, my force, times the sine of 40 degrees. Basically, this formula up here on the top right. And since this down here, this leg of the triangle right there, that is my adjacent leg, and by SOHCAHTOA, remember, adjacent goes with cosine, I know that this is going to be 50 cosine 40 degrees. And if you go to your calculator, you can do 50 sine 40 degrees, and you get 32.14 newtons. And here we get 50 cosine 40. We get 38.3 newtons. So what that means is this person who's pushing up and to the right with 50 newtons, 32.14 newtons is pushing up, trying to lift that block up off the ground, and 38.13 of newtons is pushing that to the right. Let's go ahead and do one more problem. Now normally, the problems, this is a block, normally the force is given with respect to the horizontal, okay? Like I said, like it would be right there. But it doesn't have to be, because I don't want you guys to always memorize, you know, the vertical force is always sine or something like that. So what I can do is I can do this, and I can say now I can give you this angle. And I could say that that angle theta equals maybe 50 degrees. So again, a person's pushing up and to the right on the block at a 50-degree angle with respect to this vertical part right there. And I'm just going to make up a force. So maybe that's 30 newtons. Now again, I want to enclose in my angle theta. So what I'm going to do is I'm going to draw in my triangle. So here's the force up, here's the force right, and I can kind of extend that force that I originally drew just to make it look like a triangle. Okay, so now I look at my problem and I say, all right, so this is my hypotenuse, because there's my 90-degree angle. So my 30 newtons right there, that's my hypotenuse. My angle theta is here, so far away, this is going to be my opposite. And that means that this leg right there is my adjacent. And again, remember, sine goes with opposite, so, and adjacent goes with cosine, so ka. So what I should remember is that, I'll go ahead and erase this, is that this leg of the triangle is going to be 30, and since it's my opposite leg, and opposite goes with sine, it's going to be 30 cosine 50 degrees. And this is going to be, since it's my adjacent, sorry, I made a mistake. That's supposed to be 30 sine, because that's opposite. And then this is adjacent, which is cosine, so this will be 30 cosine 50 degrees. And again, you would go to your calculator. 30 cosine 50 is 19.28 newtons. And 30 sine 50 is 22.98. Okay, so let's go back and review really quickly. You guys should be able to understand by looking at a right triangle given the 90-degree angle and the angle theta how to figure out opposite, hypotenuse, and adjacent. Then remembering these rules of SOHCAHTOA, that the opposite goes with the sine, okay, and adjacent goes with cosine. Then, when you go ahead and start splitting up forces, so the goal here is to take an angled force and to split it up into its up and down, into its left and right. What you do is you take the amount of force given, which is 50 newtons, or it could be 30 newtons for this problem, and you find out the hypotenuse, the adjacent, and the opposite, and then you're able to use the rules that I showed you guys to be able to break these forces up using sine and cosine into its horizontal and its vertical forces. And that's where we'll start off with problems really soon. Thank you.